Now that we've talked about how to factor quadratic equations, let's talk about how we can use this to solve quadratic equations. Remember, a quadratic function is any function that can be expressed in the form f of x equals ax squared plus bx plus c, where x is our input variable and a, b, and c are real numbers where a is not equal to 0. Remember, if a was 0, this whole term would be gone, and we'd have a linear function instead of a quadratic one. All right, solving by factoring. In many applications, we'll need to solve an equation that has an x squared in it. There are really three main ways of doing this, and in this video, we're going to focus on solving quadratics by factoring them. Consider an equation given by x minus 1 times x minus 2 equals 0. What are the solutions? One of the ways we can figure this out is by using what's called our zero product property that says if we have something times something else equals 0, then that tells us that either the first one has to equal 0 or the second one has to equal 0. Notably, checking each of these cases is pretty straightforward, because if x minus 1 equals 0, we can just add 1 to both sides, and we get x equals 1. And if x plus 2 equals 0, we can just subtract 2 from both sides and get x equals minus 2. In this case, there are two potential solutions to this equation, which were sort of straightforward to find because this equation was already factored. So what do we do if the equation isn't factored? Well, the general steps are to put everything on one side of the equation and 0 on the other. This doesn't work if we have another number on the other side. Our zero product property requires that there's a 0 on one side. Then we want to factor the equation using the techniques that we've talked about in this video, and then set each of those smaller linear factors equal to 0 so that we can use our zero product property in order to get our final answer. Let's practice. X squared equals 2x minus 1. Remember, the first step is to put everything on one side. It doesn't matter which side we choose, but since we've got an x squared on the left, I'm going to go ahead and move everything over to the left-hand side. Specifically, we will subtract 2x from both sides, and I will add 1 to both sides. So that's going to give us x squared minus 2x plus 1 equals 0. And remember, it's very important that we have a big ol' 0 on the other side of this equation. From here, we want to factor this. Since we've already done a bit on factoring, I'm going to skip writing all of it down. I know that I'm looking for two numbers that multiply to equal 1, that adds to equal minus 2, and there aren't a lot of numbers that do that. There's specifically minus 1 and minus 1. And so using our techniques that we learned earlier, we can write this as x times x minus 1 minus 1 times x minus 1, so that we're left with the factored form x minus 1 times x minus 1 equals 0. Again, if you want to skip some of these steps and you're able to jump right from here to here, that's totally fine. So we have x minus 1 times x minus 1 equals 0. Our zero product property tells us that either this one is 0 or this one is 0. And so we're going to have two potential solutions, x minus 1 equals 0 or x minus 1 equals 0, giving us x equals 1 or x equals 1. In fact, we get the same answer for both of them, which is totally fine. This tells us that x equals 1 is the only solution to this equation, which we could check by plugging in x equals 1 and verifying that both sides are equal. Let's try again. 4x squared minus 3x equals 1. Once again, our very first step should be to bring everything onto one side, so that we have 4x squared minus 3x minus 1 equals 0. Let's practice our factoring. We're looking for two numbers that multiply to equal minus 4, that add to equal minus 3. I'm thinking that minus 4 and positive 1 will work. And then we're going to factor this. I'm going to pull out a 4x from these first two terms, giving us x minus 1. And then I don't actually need to pull anything out of these next two terms. Just a 1 will work, giving us another x minus 1, so that we're left with x minus 1 times 4x plus 1. And remember, all of this was equal to 0 from the start. Once again, our zero product property tells us that we either have x minus 1 equals 0 or 4x plus 1 equals 0, giving us two solutions, x equals 1 or 4x equals negative 1, therefore x equals minus 1/4. As usual, consider plugging both of these in to the original equation to verify that they actually cause it to be true.